Alright guys, so in this tutorial what we're going to do is we're going to go ahead and set up a load balancer. We're going to set up the DigitalOcean droplets and we're going to set up the load balancer. In future videos we'll do more complicated stuff such as setting up Let's Encrypt with Certbot so we can get a certificate for our website, and we can also set up maybe like an application so that way we can actually see how the application works with the load balancer. But we'll just do a simple demonstration, so you guys can at least understand how the traffic is going to be forwarded. So I'm going to do is I'm going to go ahead and create a DigitalOcean droplet. Okay, and also one thing to mention is that if you guys want, you guys can use my referral link in the description to sign up for DigitalOcean. You'll get $100 of credit for 60 days to use, and if you don't use it within 60 days, it'll expire. Okay, so definitely check it out. You just need to make sure that you have a payment method, a valid payment method, in order to sign up. Okay, but yeah, it's totally free to sign up. You can use any DigitalOcean product you want, and it would be a good way to follow along with this. So let's go ahead and go over here. So we're gonna use the latest version of Ubuntu. So let's Ubuntu version 21.04. You can also select whatever operating system you'd like. I'm gonna go ahead and select the cheapest one, so 1 GB, 1 CPU. You can always resize it if you need to scale up if you want. For the data center, we're going to make sure all of our droplets are in the same data center, and we'll also make sure that our load balancer is also in the same data center region as well. So I'll just select, I guess we'll do San Francisco. Okay. Now for the next step, you're going to either do password or Shq authentication. I'm going to do SH key, so make sure you guys generate an SH key. So if you guys need some instructions on DigitalOcean, they actually tell you what you need to do. So just make sure you generate the SH key and then you paste that in over here. Make sure that you paste in the public key. So I'm going to go ahead and do that real quick. All right, so I just added my SH key. Now I'm going to go ahead and just create at least 2 droplets, okay? And droplets are just virtual machines, just to clarify. At least create 2, because if you create only 1, it's really not going to make much sense, because the traffic is only going to just forward to one single page or one single server. So you want at least 2 so you can actually see the traffic being distributed to different servers. And when you see that happening, it's going to be, wow, like that's so freaking cool. All right, so let me go ahead and name this, let's see, API. Let's call this code ring in the S1. So I'll call it S1. You can really name this whatever you want. Like if you want to do S1, E1, or like, whatever. I'm just going to call it this. Okay, so we have 3 droplets. We'll skip the tags, no server backups, and everything should be good. Like I said, just make sure you have the SH key. Okay, there's instructions on the, when you click on your SH key, there's instructions there. Okay, it's very easy, and if you already have one already, then you can just use that. I'm going to go ahead and just click on create new droplet or create droplet. So this should create all of those virtual machines for us. So you should see that those should be created in parallel. Should take about maybe like 30 seconds. Shouldn't take too long because it's a really small droplet. It's only 1 GB of RAM and 1 CPU. So it shouldn't take too long to create. But like I said, if you ever need to resize the droplets, you can always do so. All right, seems like our servers are created. So now let me go ahead and just copy this, and let me go ahead and try to SSH. It should work. It shouldn't give me any problems. Okay, so we're trying to connect to this IP address. Okay, so permanently added this. Okay, so I should be able to just connect. And there we go. I'm in the server right now. And I'm also going to connect to the other 2 as well, just so we can kind of do things in parallel. So right now this is S1. I'm going to, on my Windows terminal, so I'm using Windows Terminal, but if you guys don't use Windows Terminal, you can use like whatever PowerShell or command prompt you use. I'm just going to go ahead and open up a new pane on the side. So what I'll do is I'll do Alt-Shift-D, and that'll open up one on the right. And I'll open up one on the bottom as well. And to do that, I'll do Alt-Shift-minus. And let me just zoom in. So I'm going to connect to S2 and S3. Okay, so S1, S2, and S3. Okay, so I'm going to copy the IP address for S2. And like I said, we don't have a domain name, so we can't really connect with the domain name, so we're going to have to connect with the actual IP for now. So I'm going to go ahead and just add that. So we're logged in to S2 now, so I'll do the same thing for S3. So let's just go ahead and copy that IP address. SSH root. And there we go. We are logged into all 3 of our servers. Okay, and I'm going to move this a little bit by hitting or holding Alt-Shift and using the arrow keys to move it around. This is really why I like Windows Terminal. Okay, so now that we're logged into all of our servers, let's go ahead and do the next couple of things. So right now, if we try to actually access these servers, it's not gonna work. So if I try to like make an HTTP request, you can see right over here. Whoops. You can see that it's not going to give me anything. And it's because we don't have anything hosted on the server. We don't have anything. All right, so right now, what we're going to do is we're going to set up our environment on our servers, because right now we don't have anything on these servers. And if we try to visit these actual URLs, it's not going to give us anything. It's going to give us, it's going to say that it cannot connect or refuse to connect. So, and the reason why it's because we don't have any web server on our DigitalOcean server. So what we're going to do is we're going to set that up. So you can see over here that it gives me a site cannot be reached. Okay. And that's totally normal. So here's what we're going to do. We're going to go ahead and set up Nginx. So first thing I'll do is I'll run sudo apt update. Okay. Just update all of the, just update everything. Now, just for this tutorial, we're just going to use the root account. But obviously for like for an actual real production application, I would advise you create a different user account. Okay. Okay, so we've updated everything. So what we're gonna do is we're gonna go ahead and run apt install nginx. And like I said, if you have another account, you're gonna have to run it with sudo. So since everything is pretty straightforward, I'll just copy and paste this command on every single server. It's really just the same thing that we're doing. Okay. And there's probably ways that you can automate this. So when in the future, when you need to scale with even more servers horizontally, you can probably write some kind of code to programmatically do all this. So basically just installing Nginx and stuff. Anyways, so we have Nginx. Whoa. Okay. Let's see. So while that's installing for S3, if we just go ahead and type sudo or systemctl status Nginx, you can see that Nginx is up and running. Okay, you can see that it's up and running on, and it should be up and running on all systemctl status Nginx. Okay, and by default it runs on port 80. Okay, port 80. So there we go. So Nginx is up and running. Okay, on all 3. If it's not running, you can just type systemctl start Nginx. And if you need to, you can also reload Nginx as well. Okay, so now that we have Nginx up and running, just clear up our logs. Okay, so let's just go ahead and just validate that by visiting the URL. So what I'll do is I'll just go here, so you can see that this is S1, and you can see that this is the IP address for S1. So by default, all of these servers are going to have the basic Nginx page, because we don't have anything here. It's just a default page. You can see the IP address are a little bit different, or they are different, not a little bit different. Okay, let me just validate to make sure S3 is also working. So you can see S3 is working as well. Okay, so what we're going to do is I'm going to go ahead and just modify the page. And ideally, obviously, these pages should obviously be the same, because you're not hosting different applications. The whole point is to host the same application. but just an instance of it on a separate virtual machine. So you're not really going, so the user won't really notice much of a difference unless on the server itself you explicitly return a different application. Okay, but that's a different story. So what we'll do is I'm going to go ahead and type ls, and you can see that we don't have any files. I mean, to be honest with you, I don't really know why I typed ls. What I meant to do is I meant to type vim/etc/ not that, sorry. I meant to do vim/var/www, and we're going to edit the default HTML file, and that's located in the var www/html/index.nginx-debian.html file. So when I hit enter, you're going to see that I have this default file, and we can modify it to fit our needs. So I'll just modify that. So I'll go ahead and just type code ring IO. But, you know, actually I'll just type Anson S1. So yeah, this is S1, and we can modify this however we need. And then in future tutorials, I'll actually show you guys how to set up like a React project and how we can actually map Nginx with a React, or how we can, like, you know, proxy the request so that it serves the React app. So for now, we'll just do this. So since we're modifying the file itself, we don't need to restart Nginx. So if I refresh, you can see that on the title, I don't know if you guys can see this, but I'll have to zoom in. But you can see right over here, the title says Anson S1. Okay. And that is good. So that distincts the page. Now, like I said, in a real application, you obviously wouldn't really do anything to make a distinction because the end user is going to see this app. Okay. So I'm just modifying this just to show you guys how it works. Okay, you're going to see that it's going to propagate. It's going to go through different traffic. Actually, you know what? Let me go ahead and just change the title, and I'll also just change the tag as well. Welcome to Anson S2 server. Okay, just so that you guys can actually see it, because I'm too lazy to edit this video and zoom in and add like an effect. So I'm just going to add an H1 just so you guys can see it. There we go. Welcome to Anson S1. And we will do the same thing for this. So I'm going to go ahead and, whoops. So we'll go in here. Welcome to Anson S3. Whoops, I messed that one up. Whoops. All right, so that should be good. So now if I refresh, welcome to Anson S1, welcome to Anson S2, welcome to Anson S3. Okay, and you guys can definitely see that. Okay, so right now we haven't done anything other than we have independent servers. Each server has its own web page. All right, so now that we have set up our servers, we set up Nginx. What we need to do next is we need to set up the load balancer. So that's very easy. We're going to go over to the networking tab. Okay. And there's a lot of things that you can do. You can set up a domain. You can set up floating IPs. You can set up a load balancer, which is what we're going to do. You can set up a VPC. You can set up firewalls, and you can set up PTR records. We're going to go ahead and just click on create load balancer. Okay. And I'll just select the $10 a month one just for demonstration purposes, but you can always scale it up if you need so. So if you want to pay $60 a month for a large website, you can use that. Medium, 30, small, $10. So we're going to go ahead and choose the data center region for San Francisco. And like, for example, if I try to, let me see, what were my droplets calling? It was Anson, I think, right? Yeah, we called it Anson. Oh no, we called it code ring. Okay. So if I type code ring, you're going to see that it's not going to pop up because we have it in a, we have a different data center region selected. We need to make sure we select it for the correct data center region. So you can see over here, it tells me it's SF, I think that's 03. So that's San Francisco 3. So we select that. And now I can go ahead and just type in code and now pop up. So let's select all 3 of them. Okay. And that's pretty much it. So yeah, like I said, make sure the data center region is the same one as the droplet. Okay. And yeah, you can always, and yeah, I think that should be it. You can always, like I said, create more droplets later. All right, so everything alone should be fine. This is where you would set up the forwarding rules during the creation process. For now, we'll skip that. Let's just create it first, and then we'll configure stuff. But you can configure everything on the go. So if you want to set the rules, you can. Okay. And over here, you can set the advanced settings. So for example, you can choose what algorithm you want. So either round robin, which is what I mentioned very briefly in the first video, where we talked about load balancing, and we can also do least connections. There's sticky sessions. So sticky sessions are good if your application requires state. So with the sticky sessions, what this allows you to do is it allows you to follow up requests using a cookie. So let's say, for example, our algorithm is round robin. Basically, with round robin, it goes through server 1, server 2, server 3, and it basically does it in a round robin style. Okay, now go through that cycle. Now, let's say, for example, we have the user authenticate, and they're currently on server 1. Okay, because our algorithm is going to cycle through different servers. If the user authenticates on server 1, but they're redirected to server 2, they're going to be unauthenticated. So you can see why that's problematic. Okay, so what we need to do, and this is what we'll do later on, is we'll set up sticky sessions. And what that will allow us to do is it'll basically send a cookie. So that way, if we authenticate with server 1, or in general, if we first visit with server 1, every other request will give us server 1. And it basically persists that by using this cookie. Okay, if the cookie's not there, then it will send us to a different server. And then it will attach that cookie, and then it will keep sending us to that same server over and over again until that cookie expires. So that's pretty much how sticky sessions work. We're not going to worry about that right now. We'll do that in a later video. And over here, you can set up health checks. So this is pretty much how often the load balancer can check to see if the droplets are responding. So this is obviously recommended because if one of your servers go down, you want to obviously know what's going on. Okay, SSL. So this is going to force redirect from HTTP to HTTPS. We're going to do this in another video when we actually have a domain name and where we actually add the domain name and set up all of the records and stuff. Okay, I'll show you guys how to do that. These two things we're going to not worry about. Okay, so I'm just gonna go ahead and create a load balancer. So I'll just leave the name alone for now. But you can always give it a name of whatever you want. Everything looks good, so let's go ahead and create the load balancer. So this should take. This is definitely gonna take some time. Yeah, but in the meantime, let's see. If you want to edit your, once your DigitalOcean load balancer is done created, you can then edit these things whenever you want. Right now, it won't let us edit, obviously, and you can also view like graphs too, to kind of like see like analytics and stuff. So it's nice with DigitalOcean, is they give you things about connections, the total HTTP sessions, requests. So you can use these analytics to monitor, your load balancer. Okay, so let's go ahead and wait for this load balancer to finish creating, and then once that's done creating, we'll jump back into the tutorial. All right, so it seems like our load balancer has just been created successfully. So let's go ahead and see that. Okay, so right now, let's see. Okay, it's been created successfully. Okay. You can see that it gives us an IP address, okay, and later on in later videos, I'll show you how we can assign a domain to this IP address, because obviously you don't want your customers to visit this IP address. Like I said, essentially the customer would be visiting the customer would making requests to the load balancer, okay, and the load balancer would distribute the traffic to a server, okay. So right now, the current status is it's still collecting metrics. So with the DigitalOcean load balancer, it can actually perform health checks. You can see that it's healthy right now, and the reason why is because none of our servers are down. Okay, and that's because we had set up Nginx already. So if you decide to set up Nginx after, don't worry, it's gonna say the server is down. But once you have Nginx up and running on the default port, because right now everything is mapping from port 80 to port 80, it should be healthy. Okay, but right now, let's go over to the settings real quick. And I want to talk about the forwarding rules. So over here, the rules on the left is basically all of the incoming traffic for the load balancer. And when we want to apply it to a rule on the right, this is where it's going to forward to. So for example, all requests with the HTTP protocol on port 80 is going to be forwarded to a droplet with the HTTP protocol on port 80. If you want to do HTTPS, okay, you can go ahead and provide a certificate, which we'll do when we get a domain name. Okay. There's also like pass-through as well. But you can go ahead and just create a new certificate if you want. And with this certificate, you can actually have DigitalOcean create it for you, or you can manage it yourself. Okay, but I'll just delete this for now. So let's say, for example, you might have requests coming in on, let's say, I don't know, let's say port 81 or something, and then you want to map that to, let's see, port 80, I guess. So you can think of it like, in many instances, you're going to have requests that are being made to port 80. That'll just get mapped here. And requests made with HTTP on port 8081 would get mapped to here as well. You can also map it to another port if you want. Okay, but the default port for HTTP is 80. So that's why they have this over here. But we're going to go ahead and just click on save. Okay, and if we actually click copy, and if we go into the where's my tabs real quick? Where's my, oh, whoops, move that back here. Okay, so if I actually go to the actual IP address, okay, so this is the actual IP address of the load balancer. This is not the direct IP address of the actual application. Okay, you can see that it gives me Anson S1. Okay, whoops. So you can see that it gives me Anson S1. Okay, if I refresh, watch what happens. It gives me Anson S3, Anson S2. So it goes 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and that's because we have the round robin algorithm. Okay, if you want to configure it to a different algorithm, you can. Okay, with least connections, incoming requests are routed to the droplet with the least amount of open connections. Okay, cool. So like I said, so we have the IP address of the droplet, and it's able to go to each one of these. Now, what happens if, let's say, one of our servers go down? So let's say, let's see this. So let's do sudo. Let's do sudo, or not sudo, systemctl stop nginx. I think that should work. And let's just check the status. So nginx is currently down. Now, if we go, so we stopped the one at S3. So if I refresh the page, you're going to see that it's not going to load. Okay. Well, let's say, for example, if this server goes down. Now, if I go to the load balancer should tell me in a couple seconds, it should tell me that one of our servers are down because it cannot make a connection to that. I think the interval that we set was 10 seconds. So if I refresh, it should pop up soon. Let's double check. Interval check in seconds, 10. And you can also add additional health checks too. Like you can you can customize it. Let's see. It should update soon. I think it's just gonna take some time to make sure that the server's actually down, and it's not just like, you know, taking forever to respond. Now, in the meantime, I'm gonna wait for the health check to update. Let's go back to the load balancer, the IP address that we're using. Okay, If I refresh, you're going to see that, notice how it only gives me S1 and S2. So when S3 goes down, S1 and S2 are up and running. So even if one of our servers happen to crash for whatever reason, okay, maybe like, something happened, an error was like, let's say for example, something out of our control happened. Okay, or maybe there was some kind of production issue. Let's say, you push some code and there was some kind of uncaught exception. Okay, that might cause that server to go down. Well, customers will still be able to access your application through the load balancer, and it'll just direct them to one of the healthy servers. So you can see that it never gives me S3 anymore. It only gives me S1 and S2. Okay. So let me refresh and just double check. It should update. Yeah, there we go. Perfect. So DigitalOcean will tell you that this server is currently down. And yes, that makes sense because we just literally destroyed not destroyed, but we stopped the Nginx server. Now, if I go back here and if I start the Nginx server, okay. Now, if I go back to the IP address for the load balancer, you're going to see that, let's see, we started Nginx. What's the status of it right now? Okay, so it's active. Okay, so currently right now, traffic is not being distributed to it. And the reason why is because the load balancer still is treating that server as it being down. So we actually have to wait for it to update. So let's just wait for that. It's going to perform an update. So you'll see in a couple seconds, it should update. And once that status goes back up again, we should be able to, okay, there we go. Yeah, actually, yeah, it's fine. Okay, so you can see this S3 is back up again. So S1, S2, S3, S1, S2, S3, and there you go. So pretty much we have 3 individual servers. Each server is its own instance. Okay, we can host the same application on each instance. Okay, and if one server goes down, that's completely fine. The other server will still be able to receive communication. It'll just pretty much direct the user back to, it'll forward the user to another healthy server. Okay, and you can start to see how cool this is, because when you think of scaling your application, when you think of it from a perspective where you have an application and it's growing and you want to make sure that if something goes wrong, you have a backup server that's just up and running, well, there you go. But ideally, load balancers are really good for distributing network traffic. And you can see it's literally distributing it across all of our servers. Okay, so that is pretty much how it works. So hopefully you guys learned a lot from this video. If you guys have any questions, please feel free to leave a comment. I will try my best to respond, because this is something that I'm actually learning on my free time, and I genuinely like the concept of it. So I definitely like to hear your guys' feedback and hear what kind of architecture, what kind of solutions you guys can come up with, and we can kind of like brainstorm some ideas. So yeah, that's going to be it for this tutorial. In the next tutorial, what I'll do is I'll show you guys how we can add a domain name, and we can set up like SSL encryption. And then in another tutorial, I will actually deploy an application, a full stack application, and I'll show you guys how we can like log in and stuff, and you'll see how like everything's gonna work the way it does. So that is gonna be it for this video. Thank you guys for watching, and I will see you guys in my next video. Peace out.